So today we're going to talk about hidden Markov models, and so let's just jump right into it. So over here we have data for 10 days for a person who either works out that day or doesn't work out that day. So over here on the first row we have data on whether, say, Bob worked out that day or not. So on the first day he worked out, second day he didn't, third day he did, etc., etc. And then in the second row we have information about whether he was happy that day or not. So first day he was happy, second day he wasn't, third day he wasn't, and so on. So now essentially what we have to do is all the information we can get from him is whether he was happy or not, and then we have to find out whether he worked out that day or not. So given this data set, let's create a hidden Markov model for it. So first let's look at the probability of him working out the next day, given that he exercised that current day. So over here we see, actually let's do this in blue. So here he worked out, but he didn't work out the next day. He worked out here, and then he did work out the next day. He worked out here, and then he did work out the next day. So essentially there are two such days where he works out the following day, given that he worked out the previous day. And then there are three such days that he doesn't work out the next day, given that he works out the previous day. Those 3 days are here, here, and here, since he doesn't work out on the following days. So we have a 2 out of 5 chance that given he worked out the previous day, he'll work out again. So 2 out of 5. And then we have a 3 out of 5 chance that given he worked out the previous day, he's not going to work out this day. Now let's move on to let's look at the probability of him not working out the next day, given that he didn't exercise the previous day. So he didn't exercise this day, he did exercise the next day. Didn't exercise, didn't exercise. Didn't exercise, exercise. So we have three times that he does exercise following a rest day, so to say. So that's a 3 out of 4 chance, and a 1 out of 4 chance that he won't work out, given that he didn't work out the previous day. Now all of these probabilities that we have currently, these are called transitional probabilities. Now let's take a look at the probability of Bob being happy, given that he worked out. So let me just get rid of these arrows. So he worked out on this day and he's happy. He worked out on this day but he's sad. He worked out on this day but he's happy. And looking at all of these, we have 6 total days that he worked out of which 1, 2, 3, 4, 5 of them he was happy. So 5 out of 6 times working out makes him happy, and 1 out of 6 times working out makes him sad. Similarly, for not working out, he is sad 2 out of 4 times, so that's half, and he is happy half of the times. Now these probabilities that we just got, these are called emission probabilities. Okay, now we figured out the probability of him working out if he had worked out the previous day. So that is simply 5 out of 6. We just calculated that. The probability that he wouldn't work out, given that he worked out the previous day, 1 out of 6. The probability of him working out, given that he didn't work out the previous day, we calculated this to be 3 out of 4. And 1 out of 4 for him not working out, given that he didn't work out the previous day. Now this model, this is our hidden Markov model. Sorry. So this is our hidden Markov model. Now let's try to answer a few questions using this model. What is the probability that Bob works out on a random day? So we just pick any random day in Bob's life. And what is the probability that he worked out on that day? So the naive way to do this would just be to look at the data set we have and see, okay, there are 6 days, so we have 10 total days, and out of these 6 days he worked out, so the probability must be 60%. That's a naive approach, and since the data you have is just sampled from a larger data set, it could be very accurate. It could also be a little skewed. So a robust method, if you are already given a Markov model, a robust method to calculate this would be, so let's say E is the probability of him exercising or working out, and X is the probability of him not doing that. So the probability of him working out, E, is equal to, so let's look at the transitional probabilities. If he did work out the previous day, there's a 2/5 chance that he'll work out again. So 2 by 5 of E plus, if he didn't work out the previous day, the chances of him working out now are 3 over 4.75. So that's 3 over 4 times X. Now, to get the second equation to solve this, since we need obviously two linear equations, we know that the probability of him working out, or the probability of him not working out, is just equal to 1, because one of them has to happen. Okay, so let's solve this. One second. So E is equal to E plus B over 1 which is equal to D equal. So we essentially get E is equal to 15 over 27, and if you want that as a decimal, 15 over 27, and that's just 55.55% essentially. Okay, so for the sake of like the ease of calculation, let's just assume this to be 60%, or 6 over 10. For the rest of the questions, just because I mean 55.55 is just not an easy number to work with. But yeah, okay. Let's look at another question that we could answer. Now, if Bob is happy today, did he work out? Or, so to say, if Bob is happy today, what is the probability that he worked out? So, the probability of him working out on any given day is 60%, or 3 out of 5. And that has a 5 out of 6 chance of making him happy. So we're making 5 total columns. So when we look at him working out, 3 out of 5 chances that he will work out. So we make 3 columns here. 2 out of 5 chances that he won't work out. So we make 2 columns on this side. And the chances that he's happy when he works out is 5 out of 6. So in each column, each time he works out, he'll be happy 5 out of the 6 times. That's essentially what these faces are depicting. Sorry. And on the other side, 2 out of 5 chance of him not working out, and half of the times he's happy and half of the times he's not. So now we want the probability of him being happy given that he worked out. Sorry. Now we want to find the probability of him working out given that he was happy. So we see that these are all the times that he was happy. So given this, what is the probability that he worked out? So over here we have a total of 1, 2, 3, and 1, 2, 3, 4, 5. So that's 15, 17. So we have 17 total options, out of which 15 of them he worked out. So there's a 15 out of 17 chance that he worked out given that he is happy. And 1, 2, 3. So 3 out of 5 chance that he worked out given that he is sad. This is essentially Bayes' theorem. So to formalize this, what Bayes' theorem says is the probability of him working out given that he is happy is equal to the probability of him being happy given that he worked out multiplied by the probability that he worked out divided by the probability of him being happy. These are all values that we know, so we could just calculate it straight away. Alright, so final question. If Bob is happy and then sad, so happy on the first day, sad on the second day, which days did he work out? So essentially, what we're trying to do is we're trying to maximize the likelihood here. So we have four options. He worked out on both days. He didn't work out on any day. He worked out on the first day and didn't work out on the second day. He didn't work out on the first day and he worked out on the second day. So essentially, what we're going to do over here is we're going to calculate the probability of all four of them and see which has the highest probability. And basically, we're just maximizing the likelihood. So that's going to be our answer. So let's just go with he worked out on both days. Okay, let's calculate that first. So over here, he is happy and then he's sad on the second day. So the probability, so let's say he worked out on both days, right? So the probability that he worked out on the first day is, as we calculated before, 60%. So that is 3 out of 5. So 60% chance, 3 out of 5 chance that he worked out on the first day. Um, and the chance of that making him happy is 5 out of 6. Is that 5 out of 6? Yes, it is 5 out of 6. So we have that. Then the chance of him working out the next day, given that he worked out the previous day, is, what did we calculate? 2 out of 5. So the fact that he worked out this day is going to be 2 out of 5. And the probability that this made him sad is, I think, 1 out of 6. So now the total probability of this scenario actually happening is just 5 over 6 times 3 over 5 times 2 over 5 times 1 over 6. So that comes out to be 1, 2, 1, 5, 5. So essentially, we just get 1 over 30. Now let's just calculate another probability where he doesn't work out both days. I'm not going to calculate all four probabilities just for the sake of time, but just to go through another example. So let's say he doesn't work out both days. So the probability of him not working out on this first day is 40%. So 4 over 10, 2 over 5, and the probability that makes him happy is 1 over 2. The probability of him not working out the second day, given that he didn't work out the first day, as we calculated above, was 1 out of 4. And the probability that this makes him sad, again, is just 1 out of 2. So the probability of this scenario actually happening is 1 over 2 times 2 over 5 times 1 over 4 times 1 over 2, which is just equal to 1 over 1040. So the chance of him working out both days, like, it's more likely that he worked out both days than he didn't work out both days, given that he was happy on the first day and sad on the second day. Now, once you calculate all four of these probabilities, the next two being he worked out on the first day, didn't work out on the second day, and then he worked out on the second day and didn't work out on the first day. If you add all of the probabilities up, 1 over 30 plus 1 over 40 plus and whatever else you get, it won't actually add up to 1. And that's because these aren't all possible scenarios, right? It'll only add up to 1 when you also take all four probabilities of when he's happy and happy, and then all four probabilities of when he's sad and sad, and then all four probabilities of when he's sad and then happy. And that will essentially encapsulate all the possible probabilities for 2 given days, and all of that will add up to 1. So I think that's about it for today.